Hello everyone, my name is Madhuri Gupta, working as an assistant professor in Department of Computer Science and Engineering, Chhattisgarh Swami Vivekanand Technical University, Bhilai. I welcome you in the next exciting journey of Prolog. Before starting to go with the prologue, I wish to explain about the last lecture, which is about the expert system, where we have studied about how expert system work and what are the different expert systems right now present in the world, and how expert system simulate and how expert system work on different field of artificial intelligence and the real life application of expert system. Now, in today's topic, we will go with the prologue. Prolog, which stands for Programming in Logic, is a high level programming language designed primarily for symbolic reasoning, knowledge representation and rule based logic. I think you all have studied all those topics. It is often used in field of artificial intelligence and computational linguistics. Prolog is a unique compared to traditional imperative programming languages because it uses a declarative approach, where you specify what you want to achieve rather than how to achieve it through step-by-step instructions. Here are some key characteristics and concepts associated with Prolog. First, declarative language. In Prolog, you define relationships, facts and rules in form of predicates and then query the system to find solutions or answers based on provided knowledge. You do not need to explicitly specify the control flow or order of execution. Prolog handles this for you. Second, knowledge representation. Prolog is well suited for representing knowledge, especially in domain where relationships and rules can be expressed logically. It is commonly used in expert system and other AI applications to model and manipulate complex knowledge structures. Third, rule-based reasoning. Prolog uses a backward chaining inferences mechanism. When you query the Prolog system, it attempts to find facts and rules that support or satisfy your query by recursively searching through its knowledge base. Facts and rules. In Prolog, you define facts as a statement about the world and the rules as condition or logical implications. Predicates are used to represent these facts and rules. Fifth is pattern matching. Prolog uses unification to match patterns in queries with facts and rules. This process involves finding values for variables that make the query true based on available facts and rules. Recursion. Prolog support recursion naturally, making it suitable for solving problem involving hierarchical or recursive structure. Backtracking. If Prolog cannot find a solution with the content set of facts and rules, it backtracks and explores alternative possibilities. This makes it capable of finding multiple solutions to a problem. Applications. Prolog is used in a wide range of applications including natural language processing, expert systems, symbolic reasoning, knowledge based systems, constant logic programming and more. Prolog implementation. There are several Prolog implementation available, with SWI Prolog and GNU Prolog being popular choices. This implementation provides both an interpreter for running Prolog code and development environment with built-in editors and debugging tools. Prolog's strength lies in its ability to work with symbolic and logical representations by making it valuable tool for problem that require knowledge representation, rule based reasoning and symbolic manipulation. It is a popular choice in AI and expert system development due to its suitability for expressing and reasoning about complex relationships and rules. To install SWI Prolog and its built-in editor, follow these steps for various operating systems. Before going to this installation process, let us have the one by one steps how you can open the Prolog editors. Let us have a quick look on that process. So, let us understand what is SWI Prolog. SWI Prolog is computer software that is used to run programs written in Prolog language. It is developed by Jan Wellmaker. It is free software written in C language and can be run on different platforms like Linux, Unix, Windows, Mac, etc. SWI stands for Social Watershed Pidglik Informatica, which means Social Science Informatics. It is actually the name of the group at University of Amsterdam where Jan Wellmaker worked as an employee. Its initial release was in 1987 and its first stable release was in 2021. In this software, facts for any logical program can be written using conditional representation, and after the compilation the program can be tested for success or failure. Prolog is considered as a declarative language rather than programming language, as it is not used to solve computational problem. It is used to solve logical problems which uses rules or facts. The full form of Prolog is programming in logic. Prolog is used in much artificial intelligence, natural language processing and machine learning problems. Prolog is used to write fact or rule for problems, and then Prolog's runtime system checks those facts and rules whenever that problem is asked and return a true or false statement for success or failure of the problem. So, how to install SWI Prolog on Windows? Follow the below steps to install SWI Prolog on Windows. Step 1. Visit swiprolog.org website using any web browser like Chrome or Firefox, anything. You can see this in the display. Step 2. Click on download, which is adjacent to home. Drop down list will appear, then click on SWI Prolog. You can see in this picture. Step 3. New web page will open. Click on stable release. You can see in this picture. Step 4. After clicking on stable release, new web page will open which will contain stable version of Prolog for different platforms. Under binaries, these are two stable release for Windows. First is SWI Prolog 8.4.0-1 for Microsoft Windows 64-bit, and the other is SWI 8.4.0-1 for Microsoft Windows 32-bit. Click on the one as per your system configuration. Let us take the one for 64-bit operating system. You can see how can we select the required SWI Prolog version. After clicking on SWI Prolog 8.4.0-1 for Microsoft Windows 64-bit, a new web page will open. Check on I understand checkbox to make the download link active. Then click on the download link. Downloading of the executable file will start shortly. It is a small 11.9 MB file that will hardly take a minute. You can see in this picture. Step 6. Now check for the executable file in downloads in your system and run it. Step 7. It will prompt confirmation to make changes to your system. Click on yes. You can see in this picture, click on yes. Step 8. Setup screen will appear. Click on next. You can see this in the picture. Step 9. The next screen will be license agreement. Click on I agree. You can see this in the picture. Step 10. After it, there will be screen of installing option. So check the box for add SWIPL to the system path for all the user, and also check the box for create a desktop icon and then click on the next button. You can see this in the picture. Step 11. The next screen will be of installing location. So choose the drive which will have sufficient memory space for installation. It needed only a memory space of 50 MB. So you can browse the drive and you can select the location and you can save it. Now in the step 12, next screen will be of choosing start menu folder of don't do anything, just click on next button. Just click on next button. You can see this in the picture. And step 13, the last screen is of choosing components. All components are already marked, so don't change anything, just click on install button. You can see this in the picture. Step 14, after this installation process will start and will hardly take a minute to complete the installation. Now in step 15, click on finish after the installation process is complete. You can see this in the picture. And in step 16, SWI Prolog is successfully installed on the system and an icon is created on the desktop or laptop. Now in step 17, run the software and see the interface. You can see the interface as this picture. Congratulations, at this point you have successfully installed SWI Prolog on your Windows system. Now how to install the SWI Prolog for Mac operating system? Visit the SWI Prolog download page for Mac operating system, which is as https www.swprolog.org/download.html. Download the Mac OS version of SWI Prolog, open the downloaded .dmg file and drag the SWI Prolog application to your application folder. Now for the Linux Ubuntu system, open a terminal, run the following command to install SWI Prolog. Sudo apt-get update, sudo apt-get install SWI-Prolog -SWI-Prolog, and the built-in editor will be installed on your Linux systems. Fourth, Linux for Red Hat, open a terminal, run the following command to install SWI Prolog. Sudo dnf install epel-release, sudo dnf install SWI-Prolog. Linux other distributions, you can check if SWI Prolog is available in your distributions package repository using your package manager, for example Yum, Jaipur, Pacman, etc. The package name may vary by distributions. Using the SWI Prolog editor. Once SWI Prolog is installed, you can launch the SWI Prolog editor by running the following command in your terminal. SWI PL. This will start the SWI Prolog interpreter with the built-in editor. You can start writing Prolog code directly in the editor, and you can use the menu options to open, save and run Prolog files. Additionally, you can install external text editor or integrated development environment IDE that support Prolog for a more feature-rich coding experience. Popular choices include Visual Studio Code with the Prolog extension and Emacs with the Prolog.el packages. These editors often provide syntax highlighting, code completion and other helpful features for Prolog development. Prolog is a high-level programming language especially designed for symbolic reasoning and manipulation. It is often used in the field of artificial intelligence for tasks related to knowledge representation, rule-based reasoning and symbolic reasoning. Prolog stands for Programming in Logic and is based on formal logic and first order predicate calculus. Here is a detailed description of Prolog, its relevance to AI, how it works and a simple program example. So, what is Prolog? Prolog is a declarative language, which means you describe what you want to achieve rather than specifying the step-by-step procedures. It uses a knowledge base composed of facts and rules to make inferences and answer queries. Prolog programs consist of a series of facts. Facts, that means statements about the world, and rules, that means condition that implies new fact. It employs a backward chaining inferences mechanism where you start with a goal and work backward to find a set of facts and rules that satisfy the goal. Relevance to AI. Prolog is used extensively in AI for tasks such as expert systems, natural language processing, knowledge representation and rule-based reasoning. It excels at symbolic reasoning, making it suitable for applications where logic and rules are essentials, such as expert systems and knowledge-based systems. Prolog abilities to represent and manipulate knowledge in a structured way is valuable in AI for building knowledge base and reasoning engines. So, how Prolog works? Prolog program consists of facts and rules that define relationships and constants. You can query the Prolog systems by stating a goal, and Prolog will try to find solution by matching the goal with the facts and rules in its knowledge base. Prolog uses a process called unification to match query goals with the facts and rules. The system uses depth first search and backtracking to explore possible solution until it finds one or exhausts all possibilities. Simple Prolog program examples. Let us create a simple Prolog program that defines a family relationship. So, in Prolog we have facts. So, fact can be represented as, suppose you want to represent the parent relationship. So, we have to define parent first. So, parents define the relationship, and then John and Mary is the attribute, or you can say the variables. So, John is the first variable and Mary is the second variable. So, parent John Mary, that means John is a parent of Mary. The second example is parent John N, that means John is a parent of N. Parent Jane Mary, that means Jane is a parent of Mary. Then the relation, then the next fact is parent Jane N, that means parent Jane is a parent of N. So, how we can define the rules? So, we have mother father relationship and the rules. So, mother x y implies that parents x comma y and female x, that means mother should be female and it should be parent of y. So, likewise we have father rules. So, father x y implies parents x y comma male x, full stop. So, how this is the way how you can represent the rules. Now, define the genders. So, we have male John, that means John is a male. Female Jane, that means Jane is female. Female Mary, that means Mary is female. And then female Anne, that means Anne is female. In this program, we define parent-child relationship with facts. We define rules mother xy and father xy to infer the mother and father of a child based on the parent-child relationship and the gender of the parent. We define genders with facts. Now, you can query this knowledge base. For example, you can ask, this question mark is the symbol of query, that how you can ask the query, that who is the mother. So, question mark mother Jane comma Mary, that means who is the mother of Jane comma Mary. So, Prolog will respond with true because it is matched with the knowledge base. So, Prolog will respond with true, indicating that Jane is the mother of Mary. Next, this is a basic introduction to Prolog and its relevance to AI. Prolog's real power in more complex application involving knowledge representation, rule based reasoning and inference. Its versatile tool for AI developers to implement and reason about complex systems. Certainly, let us delve deeper into Prolog by adding more details about its key components, execution, process and more additional Prolog predicates. So, key components of a Prolog programs. Facts. Facts are statements about the world that are considered true. In Prolog, facts are used to represent basic knowledge and entities and relationships. They are typically written as predicates. Rules. Rules are used to infer new information based on exciting facts. They specify conditions under which a statement can be considered true. Rules are written as head, body, where the head is a goal to achieve and the body contains conditions or sub-goals. Variables. Variables in Prolog are represented with names starting with uppercase, letters or underscores. They act as placeholder for values that are yet to be determined. Predicates. Predicates are used to define relationship between entities. They consist of a predicate name followed by one or more arguments enclosed in parentheses. For example, parent John Mary is a predicate where parent is the predicate name and John and Mary are its arguments. Now, the execution process. When you query a Prolog program, the system starts by trying to satisfy the given goal. It searches the knowledge base, that means facts and rules, to find facts that match the goal. If a fact matches the goal, it proceeds to the next goal or terminates if there are no more goals. If no facts match the goal, Prolog attempts to apply rules by unifying the goal with the head of a rule. If successful, it adds the sub-goals from the rules body to the list of goals to be satisfied. Prolog uses depth-first search and backtracking to explore possible solution and find one or all solution if they exist. Additional Prolog predicates. Conjunction. You can use a comma to specify multiple conditions in a rule. For example, grandparents x, z is implies that parent x, y, parents y, z. This states that x is a grandparent of z if x is a parent of y and y is a parent of z. Next is disjunction, can be represented by semicolon. You can use a semicolon to specify alternative condition. For example, sibling x, y implies that parent z x, parent z y, x / equal to y. This rule defines siblings as sharing the same parent z, but not being the same person x / equal to y. Next is negation or not, or this is symbol. Prolog allows you to express negation by failure. You can use not or cut to negate a condition. For example, has no children implies that parent x, negation. This rules defines that x has no children if there are no facts that matches the parent x, empty condition. Next is recursion. Prolog supports recursion, allowing you to define rules that refer to themselves. This is particularly useful for tasks like traveling, like traversing tree structures or solving problems using divide and conquer strategies. Prolog is a versatile language for knowledge representation and reasoning, and it can handle complex problem domain through the combination of facts, rules, variables and predicates. It is widely used in AI for tasks ranging from expert system and natural language processing to symbolic reasoning and planning. Its unique approach to programming makes it well suited for domains where logical reasoning is essential. Certainly, let us explore more advanced Prolog concept features of Prolog. List and recursion. Prolog allows you to work with lists efficiently. Lists are defined using square brackets, and you can perform operations like appending, splitting and recursion on them. For example, here is a predicate that checks if an element is a member of a list. Member x, this square bracket x, that means the list of x, then the member x, then this square bracket and the tel is implies that member x, tel. The first rule states that if x is the head of the list, it is a member. The second rule recursively checks the tel of the list. Next is cuts. The cut operator is used to control backtracking. When Prolog encounters cut, it commits to the current choice and prevents backtracking to find alternative solution. This can be useful for efficiency or to restrict the number of solutions. Accumulator and tell recursion. Prolog often uses accumulator variables to accumulate results during recursion, which can improve efficiency and avoid stack overflow errors. This is known as tell recursion. For example, here is a predicate to calculate the sum of elements in a list using an accumulator. Sum underscore list, list comma sum implies that sum underscore list underscore ACC list 0 comma sum. Sum list ACC, this square bracket, that means the list ACC comma ACC full stop. Sum list ACC H T, ACC sum implies that new ACC is ACC plus H. Sum list ACC T comma new ACC comma sum. Next is DCG, that means definite clause grammar. DCG is an extension of Prolog used for parsing and generating context free grammars. It is particularly useful in natural language processing and compiler constructions. DCG rules look similar to regular Prolog rules, but have a different notation. They are enclosed in curly braces. For example, a simple DCG for recognizing a sequence of A's could look like in the Prolog program. A implies in double quotes A implies in double quote A comma A. Next is constants and constants logic programming. Prolog can be extended with constant solving capabilities, enabling you to specify and solve constant satisfaction problems. CSP's libraries like CLP-FD, constant logic programming over finite domains, provide tools for working with integers and finite domains. Now have a look on libraries and modules. Prolog supports the use of libraries and modules, allowing you to organize and encapsulate code into reusable components. You can import predicates from libraries and define your own modules for better code organizations. External predicates. You can interface Prolog with other programming languages through external predicate. This enables you to leverage exciting libraries and code written in language like C, Java or Python. Debugging tools. Prolog provides debugging tools that help you trace the execution of your program, set breakpoints and inspect variable binding. This can be invaluable for diagnosing issues in complex Prolog code. These advanced features and concept demonstrate Prolog's versatility as a programming language for various applications including AI, natural language processing, symbolic reasoning and constant solving. Depending on your specific use case, you can leverage these features to create powerful and efficient Prolog programs. So, thank you for watching and we will see you in the next exciting lecture.